Did you know that according to the World Health Organization, more than 1 billion people fall ill and more than 1 million die every year after consuming contaminated food or water? And the main culprits are bacteria. This is not only a problem of developing countries, but it is also a cause of constant concern in developed ones. In last decades, this problem has increased due to factors like climate change that is increasing the number of natural disasters that can compromise the sources of food or water, as we recently see in Mozambique. Or the aging of the world population. As we get older, our immune systems become weaker, and what is a mild stomachache in a teenager can be a very serious risk for an older person. And what about world trade? Nowadays, much of the food we put on our tables comes from any corner around the world, and in the transport and manipulation, there's always an increase in the risk of contamination. So although we currently have reliable methods for the detection of bacteria, they all present at least an important drawback to face these new challenges, like being too complex or too expensive, too slow or non-portable. The aim of my project is the development of a new electrochemical sensor for detection of the bacteria cholera that will serve as a proof of concept for a new way, a better way of detecting bacteria. How are we going to do this? We're going to use electrochemistry that combines on one hand electricity and on the other chemistry. And we're going to try to mimic nature, taking advantage of the sweet tooth of some bacteria. Because some bacteria are attracted by the sugars you have on the surface of your cells. For example, if you drink water contaminated with cholera, the toxin of the bacteria will attach to the sugars you have on the surface of your intestinal cells, and you will become infected. So what we are going to do instead is to take small needles of gold, like the one you can see here, and we are going to cover the tip of the needle with a film of sugars, the same sugars you have on your intestinal cells. So now if we pass a current through this needle and dip the needle in clean water, we will obtain an electrical signal that you can see in the blue curve. If we take this same needle and put it in water contaminated with cholera, the toxin will attach to the sugars on the tip of the electrode, and the signal will be blocked, attenuated, and you can see here the difference in the black curve. So in summary, in my project, we're going to develop an electrochemical sensor for detection of cholera based on sugars that will serve as a proof of concept of a better way of detecting cholera. A sensor that will be not only sensitive, but also simple, low, fast, and very important, portable. A sensor capable of facing the new challenges of bacterial detection in the 21st century. A sensor that hopefully someday will be capable of helping millions of people. Thank you.